Alright, gang, this is the last section of Chapter 2, which has been a pretty long section, or a pretty long chapter, with lots of stuff that we learned. And what we're dealing with in this chapter is nonlinear inequalities. In previous algebra classes, both Algebra 1 and Algebra 2, you've dealt with linear inequalities and graphing those, whether it be on a number line or on an XY coordinate system. And that was pretty simple. Nonlinear inequalities are a little bit different, and so we have to kind of treat them a little bit differently than we did in the past, because now we're dealing with products that are less than or equal to 0. Okay, for example, if you look at this one right here, we know that we could factor that out to be x minus 3 x plus 1. Now what happens is we have two things that are being multiplied, and the product of them has to be less than 0. So that means that one of them, but not both, have to be negative. Okay, because if we have a product that has to be greater than or less than 0, if they're both positive, that's not going to be less than 0. If they're both negative, that's not going to be less than 0. The only way that they can be less than 0 is if one is negative and one is positive. So what we do on this is exactly what I did at the very beginning, which is factor it. So it was x minus 3 and x plus 1 less than 0. And after you factor it, the zeros become what's referred to as critical numbers. And usually what I do is I'll draw a dotted line in that region. Our critical numbers are going to be -1 and 3. And we're going to want to test each of those intervals to see if the equation is true or not. There's different ways that you can do that. Some people like to just look at whether it's positive or negative, that type of thing. Usually what I'll do is I'll look at it and I'll assess the equation for a particular value within each region and then just determine whether or not it's true. So, for example, if my critical value is at a -1, then I'm going to test -2. Alright, when I plug in -2, the first term is a -5, the second term is a -1, which is +5, which is not less than 0. So this region doesn't work. When I plug in a 0, anytime that you have to plug in the number 0, it's actually easier to go back to the original equation, which in this case was x squared minus 2x minus 3. Okay? Because then you don't have to plug 0 in for here and here. You just have to say, oh, if it's 0, that's gone, that's gone. Is it true that -3 is less than 0? Yes, it is. So pay attention to whether or not it's easier to use the original equation or whether or not we should use the factored equation. 0 is always easier to use in the original equation. My last test zone is out there, so I will try 4. And when I do that, the first term is 1, the second term is 5, which is +5, which is not less than 0, so that zone doesn't work. So we know that only this zone works. Now the only question is, Does it include 3 and -1? I got to get some of this gibberish out of here. Here's what we found. This was a no, this was a yes, this was a no. Does it include the points -1 and 3? Well, the formula itself was x squared minus 2x minus 3 less than 0. It is not less than or equal to 0, which means it does not include those border values. Okay, so I would use in my notation on a number line a curved bracket here and a curved bracket here, and then I would make a line in between those. That's on a number line. If I was to write the answer numerically, it would be the interval from -1 to +3. Okay, hopefully you guys followed along okay on that one. So let's put it into a process that we have to do. Okay, first, factor the polynomial and find out what all the zeros are. Once you know what the zeros are, remember those are called critical numbers. Use those critical numbers to create test intervals. In the last example, we had a number line and there was a -1 and a 3, and my test intervals were here, here, and here. So those critical numbers will tell you what your test intervals are. And lastly, pick a number in each of those intervals and see which interval is a solution and which interval is not a solution. So, let's try another example. X squared minus 5x minus 6 is less than 0. You're free to pause the video right now if you want. Give it a try and see how it comes out. And when I say you're free to do that, what I really mean to say is you should probably pause the video and give it a try. Yeah, but some of you guys are too lazy to try it on your own. That's why I'm literally going to sit here and wait until you complete the problem. Okay, maybe not. Alright, this factors out to x minus 6, x plus 1. So our critical numbers are -1 and 6. So I'll draw myself a little number line here. There's -1. 6 is way out there. And of course I want to know which interval works. So the numbers that I'm going to test are going to be -2, 0, always a good one to try, and 7. When I try -2 in this, I get a -8 times a -1, which is positive, which is not less than 0. So this interval doesn't work. When I try a 0, let's see, I get -6 less than 0. That is true, so this interval works. When I try a 7, I get a 1 times 8, which is positive, which is not less than 0, so that interval does not work. Now it's not always going to end up like this. It's not always going to be the middle one or anything like that, so you literally do have to test it out each time. So my interval that works, and again, it's just a less than, there is no equal, so it's a curved bracket there and there, and everything in between. Or you can write the interval -1 to 6. Moving on, let's try another one. Pause it, try it. You may begin now. Alright, so if you notice this one, I want to factor it, but I got this thing hanging out all by itself on the right hand side. I got to bring that over. So I'm going to have 2x to the third minus 3x squared minus 32x plus 48 greater than 0. Now we learned how to do synthetic division and all that to figure these problems out, but hopefully you guys can remember that we can split that in half. We got x squared times 2x minus 3 minus 16 times 2x minus 3. So we have x squared minus 16 times 2x minus 3. Of course, we want to break this down to x plus 4, x minus 4, 2x minus 3. Holy cow, we have 3 critical numbers this time. Our critical numbers are -4, 3/2, and 4. So I always put my 0 in there because that's the one that's easiest for me to use. And this is 3/2, and this over here is 4. So I'm going to test at -5, 0, and what's between 0 and 3/2? How about 1? And how about 5? So -5, 0, 1, 5. Okay. When I plug -5 in, right here, I'm going to have 9 times 5, -5, I'm sorry. Let's back that up. -1 times -9 times another negative. Doesn't matter what it is. Bottom line is I have a negative times a negative times a negative, which is a negative. And since I'm looking at something that's greater than 0, that doesn't work. So this zone is no. Forgot to draw my lines. Ah, shoot. Okay. 0. When I plug 0 in, I end up with 0 is greater than -48. That is true. When I plug did I want to try 1? It really didn't matter. No, I didn't want to try 1. I apologize. I confused 0 with my critical number, so I'm not going to try 1. I'm going to try 2 because that's in this interval. Plug 2 in. We're right here, and I have 6 times -2 times 4 minus 3 is 1. All of that is a negative. Is a negative greater than 0? No. So this interval does not work. Lastly, I want to try 5. 5 plus 4 is 9. 5 minus 4 is 1. And this last one is 7. That's all positive, which is greater than 0, so yes, this interval works. Alright, so let's start erasing some stuff here. You don't have to erase, I do. I'm the one that doesn't have any more room. Alright, so our number line. Again, it's a greater than without the equals. So at -4, I would have a curved bracket. And right here at 3/2, I would have another curved bracket. Numerically, I write it with the interval -4 to 3/2, curved bracket. And I have another region over here that works, which is 4 to, there's no limit, 4 to infinity. Okay? Alright. Next thing we're going to talk about is rationals, and I'm going to wait for the next video to go over that one. So that's it for this one.